ছোট সিলেবাসে 3টা কুইজ দিয়ে দেই।
What?
সিলেবাস ছোট হলে তো ভালো হয়েছে।
Yeah, that's good for you, but not for me.
স্যার আমরা আসলে মিডের আগে একটা কুইজ না হয়েছে তো এখন পরে যে আসলে
So we have only given one quiz before mid. That's why we were planning to.
Okay,
give
so
one.
based on the lecture, what we have done in the previous class as well as today's class, but I missed two of the classes last week for section C. So they will have only one class. That's why I'm saying that.
স্যার তাহলে অল্টারনেটলি স্যার যদি আমরা মিডের আগের সিলেবাসের উপরে একটা অ্যাসাইনমেন্ট দিয়ে দিতেন মানে একটা কুইজের কম্পেনসেশন তাহলেও স্যার হয়ে যেত মিটিগেট হইতো।
Actually, on the last quiz, I will be taken. I will take the. It's based on the DC to DC converter and the DC to AC converter based on the renewable energy integration into the grid. So that will be the open-ended assignment, the last one, and that will be the mandatory one. So this quiz will have 5 compulsory for everyone, and the first 3, 2 of them will be taken for the quiz mark. So I have already made plan for the and one open-ended assignment. So that's why no more assignment is will be given. But you can give one quizzes based on what for section A and B, what we have learned in the previous class and the class today. But let me cover the same topic for section C, and then how about the next week we'll have exam, but the syllabus will be based on what I will covered today. So I will take the quiz based on the 2 close classes syllabus. So I think that is okay, right?
Okay, sir.
But the quiz should be on not on the next week, next of next week. Okay, so that I can cover the lecture for section C as well.
Sir, is Wednesday okay for you to take the quiz? Wednesday.
Wednesday, what time?
Sir, lunchtime.
If you do this thing, then I will take class on Wednesday after the quiz. Will that be okay for section A and section B?
Sir, can you take quiz on Tuesday and Friday? You are available.
Then, sir, we can take the quiz on Tuesday then.
So if you're available on Tuesday, we can take on Tuesday.
Tuesday, okay, I can take quiz on a Tuesday, but that would not be in the next week, next of next week, right?
Okay, so next of next week.
Because for next week, the duet admission is from Sunday to I think it will examine the script until Wednesday. So me and Mijan Bhai will not be available throughout the next week. So that's why I am very much confused about the classes on Tuesday and Wednesday. But I will definitely take classes on Friday.
Okay, sir.
Okay, so should I start the class?
Yes, sir.
So how many weeks do you have before the final exam? 15 weeks or 14 weeks? I have asked Faisal Bhai, he said 15 weeks.
Sir, 7 weeks. 8 week already gone. 1 week.
So we have still 7 weeks, including this week, right?
No, sir, 6 weeks including this week.
But Faisal bhai said that the total week count is 15 weeks.
He probably told about the whole semester. Whole semester is 14 weeks plus 1 week for this semester only.
1 week for the
For this semester only, but conventionally it's only 14 weeks.
okay. Okay, so let's just start the class. Today we'll start the class from a special type of DC to DC converter that we discussed in the previous class for section A and B, and that is, what was the name? Flyback converter. It is basically a isolated converter. So why it is isolated converter? Because as we said, the output and input for the converter that we have discussed so far, like the buck or the boost or the buck boost, choke, SEPIC converter, the input was directly connected to the output through some switches or inductor or capacitor. But in this case, for the flyback converter, we'll use a transformer as an isolation medium. So the primary end of the transformer is not directly connected to the secondary. So the input and output will be electrically separated. So basically what we have here, so we'll have a simple transformer. And suppose this is my transformer primary. And we have a transformer secondary like this. And from the secondary, we'll connect a diode to a capacitor, and it will be connected.
Which book are you using for this flyback converter?
Sorry, I didn't get you.
Which specific book are you using for this flyback converter?
Actually, I am still searching for the best book to refer, but there are some books that give some description about it. So I would advise you to follow my lecture, and if I get any suitable book, I will let you know. Okay.
Okay, sir.
So suppose this is my V naught R. This current is my ID current. This is IC. This is I naught. And for the primary side, it is connected to the source. Suppose this, it should be a DC one. So I can hear some noises. So can you switch your microphone off? So suppose this is my VS. So can you tell me what is the equivalent circuit of the transformer? For section A and B, I told you to study the transformer circuit. So basically, okay, so what is the transformer circuit? Equivalent circuit? Anyone?
So we write-
basically, here, there for the transformer, there are two windings. So basically, we'll have two windings for the transformer. So basically, this is the transformer. Suppose this is this side, it's a 1:n trans ratio transformer. So basically, this two winding is represented by these two coil for the idealistic case. So for the ideal transformer, basically you will find only two coil, and since our dot polarity is like this, so this is my idealistic transformer equivalent circuit. But for the idealistic transformer, we consider that there is no current needed for the flux to flow through the core, but which is not actually possible in a practical transformer. So at least we'll have to supply a minimum amount of current to produce the mutual flux that will flow through the core of the transformer. So basically, if you consider an idealistic transformer, although it is an idealistic one, but still you will have a parallel branch that will only produce the current, which is known as magnetizing current, so that this current will produce the flux that will be the mutual flux phi m. So this is my flux, mutual flux phi m, that will link up two coils. So that is the very basic or very close to the idealistic model of the transformer. And if you go to more and more practical approach, you will find that there should be a leakage inductance and there should be a resistance. But since we are using very small transformer, electronics transformer, so we'll consider that the loss of the transformer or the leakage flux of the transformer is very small. So in that case, we'll neglect that portion. So now, if this is my idealistic equivalent circuit of the transformer, so basically this two winding is represented by this thing. So now, if we connect that to a source through a switch, this should be my T1. This is my primary winding side. So suppose this is my Vs. And for the secondary side, we'll have a diode, and then we'll have a capacitor that will be connected to the output. So suppose this is my V0. This is my ID. This is IC, and this is I0. So can anybody tell me whether the transformer is a positive coupling device or negative coupling device?
Positive.
No, transformer is a negative coupling device. Why is that? Because if the transformer draws current like this, so the flux in the core that will produce the current that will produce the mutual flux in the core will be in this direction. You know how to get the direction of the flux, right? Using the right hand rule, right? So the secondary voltage here, it will try to produce a current in a direction so that this current will produce a flux that will oppose the original flux. So which way then the current should flow? The current should flow in this direction like this, so that the flux the current produce, it will be opposite of the mutual flux phi. You got my point, right?
So can you repeat this?
So as I said, if the transformer primary winding, if you give a primary winding current to a transformer, So this current will produce a flux, right?
Yes, sir.
So based on that, what will be the flux direction?
Upwards.
Upwards. So suppose you have a winding at the secondary as well, like this. So the flux produced by the primary current will be in this direction, right? And for the primary, the polarities should be like this, right? So that the current is going from negative to positive in this direction, right? So
Yes, sir.
what should be the direction of the current in the secondary of the transformer? Suppose this is my phi m. So the current in the secondary, it should be in such a way that the current here produce a flux in the opposite direction of the main flux. You got my point, right?
Yes, sir.
So for the battery, the current flows from negative to positive, right? So in that case, the current is entering here and leaving like this. So the polarities here, it should be like this, right? Because for the source, the current goes from negative to positive. So in that case, if you put a dot polarities here, the positive terminal, sorry, so in that case, there is a dot polarities like this. But one thing you can see, the current in the primary is entering the dot, whereas the current in the secondary is leaving the dot. So if two currents are not entering at the same time or the leaving at the same time, the coupling coefficient, it should not be positive, it should be negative, right? And the current in the secondary is opposing the flux produced by the primary current. That's why we are saying for transformer, the mutual coupling coefficient M is always negative, not positive. Do you get my point?
Yes.
So, as we did for the analysis of so many DC to DC converters, so we'll consider that the T1 is on for T1 is on for TS time. So if T1 is on, so what will happen here? So if the T1 is on, then what will happen to the transformer circuit? So for this case, if you consider this circuit, what will happen to that? So my circuit will look like this. This is my primary side. You will have two winding. And this transistor is turned on. So it will be shorted like this. This is my mutual inductance, magnetizing inductance. This is my Vs. And the secondary. Now, if you put Vs, what should be the polarities across primary winding? It should be positive and this should be negative, right? So if this dot is positive, this dot should be positive as well and it should be negative, right? So the secondary, the current should be flowing in that direction, but you have a diode connected like this. So can you tell me whether the diode will be turned on or turned off?
Turned off.
Turned off, right? So if the diode is turned off, then we can replace the diode by a open circuit, right? So now this is my IC, this is my I naught, this is my plus minus V naught, and this is my 1:n transformer. So now can you tell me, since the secondary current cannot flow through the circuit, so the current in the primary circuit in this winding, it should be also zero. So all the current that the source will provide, it will go through the magnetizing core, magnetizing coil, and it will come back to the source. So now what should be the voltage across the magnetizing coil?
VS.
So my VLM, it should be equals to my VS,
VS.
right?
Yes, sir.
So what should be my ILM then? ILM, it should be VS over LM multiplied by D into TS. You know how to get this equation, right? We have discussed that several times in the class. Now, again, your ILM, that is this current, ILM, that should be equal to your source current, right? So we can write ILM, that should be equals to your source current. And what about the relationship in the secondary side? So from the secondary, what we can write, since your ID current becomes zero, so we can write ID equals to zero. And what is the relationship between IC and I naught? So we can write IC plus I naught, that should be equals to zero, or we can write IC, it should be equals to minus I naught, right? Any doubt about that?
No, sir.
Okay, so now,
Sir, in equation 1, shouldn't it be del ILM?
okay, yeah, it
Sir,
should be del I.
equation 1.
Yeah, it should be del IL. So now this is your equation number 2. So if I try to draw the waveform T, and suppose this is my VT1. So when I am putting pulses here, T1. So suppose I am just considering this into 2 equal halves. So for this time, the T1 is on, and for this time also the T1 is 1. So in that period, what should be the voltage across the magnetizing coil? So during this portion, what should be the voltage? It should be
VS.
VS.
VLM. So it should be VS, right?
Yes.
And what should be your current?
I. Yes.
So now if you draw that,
I.
your current should be charging like this, right? So this should be your ILM. Okay. Again, then my input current, and we can write it as IT1 as well. So my input current, or that current through the transistor, we can write it as, so this current, it should be my IT1 or IS. It should be the same current for the positive half, right? So it should be the similar current that you find here. And now, what should be your capacitor current? IC. What should be your capacitor current?
Minus V naught by R.
So it should be minus I naught, right? During that session. So it should be minus I naught, we can write it as V naught over I naught, right? Okay. So now, for the time when we consider T1 is off for 1 minus D multiplied by TS time, So what we can write? So during that time, what should be my waveform or the equivalent circuit? So now the equivalent circuit will look like this. So suppose you have a DC source and then you have a magnetizing coil and you have a primary winding of the transformer, and this portion, it is open circuit, right? Because your T1 is off at that time. And this is my dot, and the secondary, it is connected like this. You have a diode, and then you have a capacitor, which is connected to the output to a load. So suppose this is my V naught, and this is my 1:n transformer. So now, previously, the inductor current, the magnetizing core current, ILM, it was going in that direction. But now, since the coil, the transistor is now open, so,
On your left, on your left.
so how the current will react now? Can anybody tell?
So there will be no current flow.
What?
So there should be no current flow.
So during this period, what is happening? The current is charging, right?
আর দুইটা কয়েলের মধ্যে কারেন্ট ফ্লো হবে ওই সাইকেল
So the current, it will go like this. It will circulate between two coils so that the current can discharge. So now, if the current is going in that direction, so for this coil, what should be the polarities of this coil? This should be positive terminal, this should be negative terminal, right? So
উল্টা হবে স্যার
the current is going from this in this direction, circulating this. So this should be positive terminal, this should be negative terminal. So this dot, it is negative. So this dot should be negative and this should be positive. So in the secondary, the current will try to flow in this direction. So if the current is trying to flow in that direction in the secondary, so what will happen to the diode now?
শর্ট সার্কিট
ফরওয়ার্ড বায়াস
So if the diode is now in the forward bias, so we can consider the diode like a short circuit switch, right? Like this. So now this is my diode current ID, this is my IC, and this is my I naught. So now can anybody tell what should be the voltage across the secondary?
ভিসি মাইনাস ভি নট
No.
Sir, V naught.
These three are connected in parallel, right? So this
V
should
naught.
be my
শুধু
V naught.
জি স্যার ভি নট
So this, if this is V naught, what should be the voltage across this coil or this coil? It should be negative positive. This is 1:n transformer. So the voltage in the secondary, it should be stepped out by n amount, right? So in the primary, it should be stepped down by n amount, right? So in the primary, the voltage should be V naught over n, right?
Yes, sir.
So now what should be the voltage across the magnetizing coil? VLM. It should be minus V naught over
ভি নট বাই
n, right? So here the voltage across that, it should be this value here, it should be minus V naught over n. And since this voltage is negative, so as you can see, this current, it will try to discharge through this loop. So now what should be my del IL M? It should be minus V naught over n into LM multiplied by 1 minus D into Ks. That should be your equation number 3. And in that case, what should be my IT1 and IS? It should be 0, right? Because this terminal, there is no closed path. So this current, IT1 or IS, it should be equals to 0, right? So this is the primary one. And then what we can write from the secondary? So,
Oh, sir,
yeah,
sir, I didn't understand the part, minus V naught by N. What's the N, sir, again?
okay. So now this is the transformer, right?
Yes, sir.
You have polarities like this. So if this is 1:n transformer, so if you put 10 volt here, what should be the voltage across the secondary? It should be N multiplied by 10, right?
Yes, sir.
So the primary side voltage, it should be N times lesser than the secondary side voltage, right?
Okay, sir. Yes, sir.
You got my point now?
Yes, sir.
But in the previous case, we considered the polarity to be like this. But now the polarity is what? This is negative, this is positive. So meaning that this terminal will be negative, this terminal will be positive. So this polarities is the opposite polarities of the previous case, right? So that's why we are putting a negative sign here. You got my point, right?
Yes, sir. Understood.
Okay, now for this node, what should be the relationship? So we can write ID, it should be equals to IC plus I naught, right? So we can write your IC, it should be ID minus I naught. ID minus I naught. So this should be the relationship. So based on that, if I try to draw the circuit output, what we can write? So now, since the voltage is negative, so what will happen to the current? So this current, it will decrease and this voltage will go like this. So that would be my VLM. And the current in the magnetizing portion, it will go like this. And this middle point, we can consider it to be the average current. So suppose we are considering it as IL. And during this time, what should be your IT1? During this negative portion or the dropping
Zero.
portion, it should be
IT1 is to
Zero.
zero, right? So again, you will have this current when it will charge like this. So that should be your IT1 or the input current. And what should be the current through the capacitor? It will
ও
have
আচ্ছা, আমি আজকে বুঝছো সিআর ক্লাস শেষ হওয়ার পরে 2-3 ঘন্টা ক্লাসে ছিলাম। এই তো শোনা যাচ্ছে।
so for the dropping part, the current through the capacitor, it will be like this. So this current, it should be ID minus I naught. You got my point, right? Do I need to explain anything here?
So can you repeat IC?
Yeah. So during the first half, what was the relationship? IC was minus I naught,
Minus I
right?
naught. Yes, sir.
Okay. So now for the IC during this part, what is my IC?
So ID minus I naught.
ID minus I naught. So your IC, what is your ID? What is your ID? We don't know that yet, right?
Yes, sir.
So now let us try to make a relationship between your ID and I naught and input output characteristics. So we know for the inductor voltage, for the total time period, V of lambda, VL lambda D lambda, that should be equals to 0, right?
Yes.
So based on that,
আমাকে বলে আসো সবাই জানতে হবে না।
সবাই জানে ভাই গ্রুপে মেসেজ দিচ্ছে
So we can write that during the transistor turn on time, what was my voltage? Vs. So we can write Vs multiplied by D into Ts. And during that time, when the transistor was off, so V naught over N 1 minus D multiplied by Ts, that should be equals to 0. So based on that, we can write Vs multiplied by D into Ts, V naught over N 1 minus D into Ts. So based on that, if I cancel out Ts, we will get what is my V naught? V naught should be N. Oh, this should be D, right? Capital D. So N multiplied by D over 1 minus D multiplied by Vs. So this is the equation of what?
Boost.
Buck boost converter, right? So now, can you tell me what should be the diode current? The diode current, how we get the relationship between the diode current? So we know your Vs, Is, average power given from the primary, it should be equals to your V naught, I naught, right? So what is your Is? This current. So the middle point of this, it is your IL, right? What we get here. So what should be your Is? We have derived this equation several times in the class. Can anybody tell? What should be your Is?
So V naught by R.
So your Is should
IL
be IL multiplied by D, right? And your V naught
Yes, sir.
just got N multiplied by D over 1 minus D multiplied by Vs, and it should be I naught. So based on that, if we cancel D and Vs, we'll get I naught, that would be N multiplied by 1 minus D into IL. Now, during this time, if the voltage is stepped down here, on the secondary, the voltage is stepped up, right? So if the voltage is stepped up, what will happen to the current?
Current goes down, step down.
So the current will step down by an amount, right? That will be the trans ratio, right? So in that case, what will be my ID? Your ID will be Im over N, right?
Yes, sir.
So what will happen to this portion? So this is, what is my diode current here? So as you can see, your diode current, so this portion, if I try to draw here, so what will be my diode current? Suppose this is my ID. So during this portion, your diode current would be 0, right? Because the diode is open circuited when the transistor switch was on. But what will happen to the diode current? when it is switched on, so it would be Im over N, and the diode current would look like this. Exactly the same shape of this dropping portion of the current, but it will be reduced by an amount Im over N because of the trans ratio of the transformer. Did you get my point?
So ডায়োড কারেন্টের ইকুয়েশনটা বুঝি না আইএম বাই এন হলো কি রকম
Because suppose, as I said, the transformer, it is 1:n transformer, right? So if it is 10 volt, what will be the voltage here on the secondary? N multiplied by 10 volt, right?
Yes, sir.
If the primary side current is ILM, what should be the secondary side current?
ILM by N.
ILM divided by N, right?
জি স্যার বুঝছি
So when this diode is operating, if this current going through the magnetizing coil is ILM, what should be the current that is going through the diode? That current is the same current that is going through the secondary of the transformer, right?
Yes, sir.
জি
So
স্যার
what
বুঝতে
should be this
পারছি
current? It should be ILM divided by N, right?
Sir, এগুলো average current না?
No, average current. This is the actually this is the current. So what should be this average value? What should be this average value?
So integrate করতে
This
হবে।
is the instantaneous current, right? And the average value of this current is IL. So what should be the diode average current?
IL by N.
IL by N into 1 minus D.
IL divided by N into 1 minus D, right?
D.
Yes, sir.
That should be your diode current, ID. Right? Okay.
Yes, sir.
I made one mistake here since one N is here. So if I take this on this side, so it should be ID over N. So this current here is the same current here, right? This current and this current is same, right?
Yes, sir.
So in that case, we can write it as ID, average diode current. It would be the same current that is the average current of the load. So what will happen to the average current of the capacitor?
So 0.
So the average current of the capacitor, it should be 0, right? So that's why we say this area, it should be equals to this area. Since this is I naught, so this diode current, if you revise this thing, minus I naught based on this equation, it should be shifted from the diode current by the I naught amount. You got my point?
So can you repeat the last part?
Yeah. As I said, for the first half, what was my capacitor current? It was minus
Minus
I,
P naught by
right?
R.
Okay. So what is the current here? Dropping one. This is my current in the primary, right? This magnetizing current, where it is? It is in primary.
Primary.
So what should be the diode current in the secondary?
ILM by N.
ILM by N. This is this current, right?
Yes, sir.
So this current, if you shifted it by an amount I naught, so this current should be your this current, right?
Yes, sir. Got it.
Do you understand now?
Yes, sir.
So these are the equations for the flyback converter. If you have any question, you can ask me. Otherwise, I will go to the next topic. Is there any question so far?
Sir, so in this case, the average diode current is equals to the average output current, right?
Right. Because as you can see, during the
Yes,
normal
yes.
operating condition, if there is no diode current, so your current here, it should be, there is no entering current, right? So in a normal case, this is diode current, this is your capacitor current, and this is your output current. So what is the relationship? ID equals to IC plus I naught, right? So average value of ID, it should be average value of IC plus average value of I naught. So what is the average value of the capacitor current?
0.
0.
Right? We have discussed that several times. So your average diode current, it should be equal to your average load current, right?
Yes, sir.
Sir,
Do you understand clearly? Any question regarding this? So this circuit is very important for your final exam. Okay. So now
Sir,
we are done with DC to DC converter. I will go on the next topic, which is full bridge rectifier. Last call. Is there any question regarding this flyback converter?
স্যার ওই যে আই নোটের শিফটের ব্যাপারটা একটু আরেকবার ক্লিয়ার করলে বেটার হতো।
I naught.
স্যার ওই যে ILMN ডিভাইড বাই n মাইনাস আই নট, জি স্যার এইটা।
Okay. So as I said, suppose this is your IC. This is your IC and this is your I naught. I naught. So suppose whether there is a diode or not, we don't know. But suppose this is some current I. So what is the relationship? I equals to what? IC plus
আই নট স্যার।
I naught, right? So when the diode is not working, so what will happen to I? What will happen
Zero.
to I? I becomes 0, right? Okay, so now let me redraw that again here. So suppose so this is my current. Suppose this is my primary current. This is my ILM. And this is the average current of that. Okay, so what will be my diode current? I diode. What should be my diode current? Sorry, my drawing is horrible. Okay. Oh. So what should be my diode current? During the charging period, is there any diode current?
No, sir, it should be 0.
So this time this is 0, right? But during this portion, there should be a diode current. But is that diode current the same current that we will find in the primary?
No, sir.
This current should be what? ILM divided by N, right? Right?
জি স্যার।
Because the secondary of the transformer the current will be stepped down by the trans ratio, right? So what would be the average value of this current then? If primary side average current is IL, then the secondary side average current would be IL over N, right? You got my point?
Ji sir.
Okay. So now, what should be your output current or the load current? I naught. It's a constant current, right?
Yes sir.
So now, what should be your IC? You know, ID equals to IC plus I naught, right? So when your ID is 0, what should be your IC? IC should be
Minus
minus
I naught.
I naught, right? So here you will get minus I naught. Minus I naught, right? Now, when the diode is operating, what should be your IC? IC should be what? ID minus I naught, right? Is it? So what
Yes,
is the ID? This current, right? This current, right? So if you subtract this current from this current I naught, then you will get the IC current, right? So what will be your IC current then? This current, it should be ID minus I naught, right? So this waveform, it would be shifted by I naught amount to get this current,
Yes, sir.
right? Did you get my point?
Ji sir.
Any question regarding this?
এবারে কারেন্ট জিরো কিভাবে একটু আবার
What?
এভারেজ কারেন্ট জিরো কিভাবে হলো যদি একটু আবার
Why average current? Is zero. Why is average current 0? You tell me why is that? Okay, so what is the area of this current? Or what is the area? This is your I naught, right? So what is this area?
minus into DTS.
I naught multiplied by D into
DTS.
TS, right?
Mm.
What is this area? What should be the average value of this?
Yes.
So what was the average value of this one? IL,
ILM divided
IL,
The half.
by N.
IL by N, right? Minus I naught. So IL by N minus I naught. That should be this cross-sectional line, right? A straight line. That should be the value of this thing. And what should be the time for that? D in 1 minus D, 1
Into
minus D
T.
multiplied by TS. So what should be the total area then? I naught multiplied by D into TS plus IL over N minus I naught into 1 minus D into TS. So here you get I naught d into Ts plus IL over N 1 minus d into Ts multiplied by what you get. So minus I naught into 1 minus d into Ts, that should be equals to 0, right? So here, what you get I naught d into Ts. Here you get minus I naught into Ts and minus minus plus. So plus I naught d into Ts, and then we have this term IL over N 1 minus d, that should be equals to 0, right? So this term will cancel out. So what should be this value? Here it will also have Ts. So I naught is what? Minus I naught plus IL over N 1 minus d, that should be equals to 0, right? How this is possible? Because, oh, okay, we are calculating the total area, so we should not put this 0, because finally we will get this value 0. So what is your I naught? I naught is the same value that you get here, right? So this thing, this term and this term are equal, so eventually you will get 0, right? So that's why we say the average value of the capacitor current, it would be 0. We have discussed that several times in our previous classes, right? The boy who asked the question, did you get my answer? Get your answer?
Yeah, yes, I can.
Any question regarding this? Okay, so now we'll start talking about full wave rectifier. So for the full wave rectifier, we'll have port diode, and for the simplest case, we are only considering a resistance, and we'll have a source that will be connected like this. Or sometimes, suppose this is my V naught, or sometimes you might use a central tap transformer that will have 2 winding. And suppose for the positive half, it will go like the current will go through this diode. So suppose this is D1, this is D2. So the polarities will be like this. Suppose this is my V naught and this is R. So I think you have studied center tap transformer and the full wave rectifier in your electronics class, right? So I will not get into too much detail of that one. Is there anyone who doesn't know how to draw the waveform for a full wave rectifier? Because during the introductory class, we have discussed about the waveform of the full wave rectifier. Does anybody have any problem regarding the operation of the full wave rectifier?
So সেন্টার ট্যাপে সেকেন্ডারিতে একটা ওয়াইন্ডিং হবে না?
Yeah, we are considering 3 tapping. So this is 1 tapping, this is middle tapping, and this is 3rd tapping. So for the central tap, actually here you have 1 winding and there is a center tap here, right? So
Yes, sir.
up to this point, we are considering one coil. And from here to here, we are considering another coil, because suppose you have a primary voltage VP, so that should be your secondary voltage, and that should be another secondary voltage, right?
Yes, sir. Both are same.
Is there any question regarding this? Okay, so now during the positive half of the input, so suppose this is my positive half, this is my input. Suppose you have a simple sinusoidal wave. This is my V in. So during the positive half, the polarities of the voltage will be like this. So it will try to flow the current in this direction. So so it will go through this diode, through the load. It will come back like this, and it will go through diode D2, and through that, it will come back in this direction. So the polarities of the output will be in this direction, and hence we can write our output voltage V0 same as the input, but it will have the waveform like this. And then during the negative half cycle, what will be the current direction? So the polarity it will be in this direction, so it will try to flow the current in this direction. So hence this will go like this through diode D3. So for that first case, your D1 and D2 will operate, but through the load, the current will be in the same direction what we got for the positive half cycle. And during the negative half cycle, it will go like this through diode D4, and it will come back in this path. So hence, although my input is sinusoidal, you have a positive half and the negative half, but for the load, the diode are connected in such a way that you will have two symmetrical waveform. So what should be the average value of this waveform? And what should be the current? So if you have a voltage waveform like this, so the current waveform, it will have a similar waveform, but this current, it will be reduced by an amount
R.
V0 over R, right?
Yes, sir.
Okay. So now, what should be your V0 average current, average voltage? It should be 1 over pi. Then
V0 sine omega.
it should be 0 to pi Vm sine omega t d of omega t. So it should be 1 over pi. You can take Vm out. So 0 to pi sine omega t d of omega t. So what should be your, it should be Vm over pi sine omega t d omega t, it should be minus cos omega t pi to 0. Hence, you will get Vm over pi multiplied by what? Here it should be minus cos pi plus cos 0. So this gives you 1. This also gives you 1. So it should be twice Vm over pi. This should be your V average current, right?
Yes, sir.
So what should be your I naught then? I average current, it should be V average current over R. So it should be twice Vm over R multiplied by pi. That should be the equation for input, output voltage, DC voltage, and output DC current. So now what should be the RMS value? IRMS. How can we define IRMS? It should be 1 over pi, 0 to pi, Vm sine omega t whole square d of omega t. So here you will get Vm square over 2 pi. I took 2 extra here because I want to make 0 to pi, then 2 sine square omega t d of omega t. So what should be 2 sine square omega t? What should be 2 sine square omega t?
1 minus cos 2 omega t.
Okay, so it should be Vm square over 2 pi, then it should be 0 to pi 1 minus cos 2 omega t multiplied by d omega t. So if you take the integration of cos omega t, what you will get? So Vm square over 2 pi. So for the first term, it should be omega t minus, here you should have half sine 2 omega t, and then you have pi and 0. So for sine 2 pi and sine 0 becomes 0, right? So finally you will get Vm square over 2 pi, and for omega t it should be pi minus 0. So finally we can write Vm over this pi will cancel out. So we will finally write it as Vm over root 2. That should be your RMS value, right? Is there any question regarding this? I think you know the calculation, right? Is there any question regarding this integration?
No, sir.
Okay. And then what should be your IRMS? It should be VRMS over R. So it should be Vm over root 2 R. That should be the equation for IRMS, and this should be the equation for VRMS. So now, if you were asked to define the efficiency of the circuit, so what is your efficiency? Efficiency. And we defined efficiency as PSC over PDC. So what is your P multiplied by 100%? So what was your PSC? PSC was what? VRMS over R divided by V naught whole square over R, right? So if you do that, what you will get? So what is your VRMS? What is your VRMS? Vm over root 2. So this R and this R will cancel out. So it should be VRMS square over V naught square multiplied by 100%. So what is your VRMS? Vm over root 2 whole square divided by, what is your VDC? 2 Vm over pi. 2 Vm over pi whole square multiplied by 100%. So we can write Vm square divided by 2 over 4 Vm square over pi. So this Vm square will cancel out. So we can write it as pi over
I square.
oh sorry, we just made one mistake. It should efficiency should be VDC over VSC. So this term we made this calculation here. Your PDC over PSC, because we don't want any ripple at the output. So we'll consider that your output should be purely DC. So in that case, it should be your PDC over PSC. So it should be V naught square over R divided by V RMS square over R. So you can write V naught square over V RMS square. So your V naught square over was your 2 Vm over pi whole square divided by VRMS was Vm over root 2 whole square. So we'll get 4 Vm square over pi square divided by Vm square over 2. So this Vm will cancel out and this 2 will go up. So 8 over 4 multiplied by 2 over pi square multiplied by 100%. So can you tell me what is this value?
Sir, 81.05.
81.05%, right? Okay. So now if you want to get the form factor, FF, it is defined as VRMS over VDC multiplied by 100%. So what was my VRMS? Again, Vm over root 2. What was your VDC? 2 Vm over pi. So this Vm will cancel out. So pi over 2 root 2 multiplied by 100%. What should be this value?
স্যার 100 এর উপর হয়েছে।
Should not be. Yeah. Okay. So what should be the ratio then?
1.11.
Okay.
So isn't form factor higher than 1 always?
Yeah. The form factor should be greater than 1.
Yes,
So
sir, it was
should be
1.21 probably
1.11.
in previous case.
That is fine. Because this term, it should be higher than this term. Because if you remember, your VRMS was what? VDC square plus VSC square, right? So VRMS was higher than your VDC value. So that's why this ratio, it should be higher than 1. And if it is 1, it means that the output is purely DC. There is no ripple on top of the DC factor. You got my point, right?
Yes, sir.
Yes, sir.
So now, if you try to get the ripple factor. So that's what I was saying. We can see how much ripple or what percentage of ripple you have in your output voltage as compared to the DC component. So your ripple factor, RF, it is written as Vrms over VDC whole square minus 1 into 100%. Or since this term is your form factor, so we can write it as form factor square minus 1 into 100%. So in that case, we can write 1.11 whole square minus 1 multiplied by 100%. So what should be this value?
So 48.17%.
48.17%.
17.
Okay. Now, what should be your transformer utilization factor? TUF. What was that? That was your PDC over VRMS multiplied by IRMS multiplied by 100%. What was your PDC? It was V naught square over R divided by VRMS. VRMS was what? So your VRMS was VM
by
over
root
root 2. So we can write VM over root 2 multiplied by IRMS is nothing but VRMS divided by resistance. So it should be VM over root 2 R. And what was your V naught? That is your VDC. So it should be twice VM over pi whole square divided by VM square over 2R multiplied by 100%. So what should be this value? Then it should be 4.
So there should be a R in V naught
I
square by R.
square. And then, okay, so this should be divided by R, right? So this R will cancel out. So meaning that this should be Vm by pi square over half, right? So 8 over pi square multiplied by 100%. So again, this should give you the same value. We got it previously, right? So this value. So what was that? 81 point something, 81.05%.
Sir, is transformer utilization factor and efficiency the same? In efficiency, you have like PDC by PSC. And in transformer utilization factor, it's also again the same, PDC by PSC.
ওরা মানে স্পট গুলোর এন্ট্রি কি ওরা দিবে?
No, the thing is that suppose you have a transformer, right? And from the secondary, actually, this side, as you can see, this voltage is VSC, right? And the current they are providing, it is also ISC, right? And this is, suppose this is AC to DC converter that you are using. And here you are getting the output voltage V naught. And the current you are providing here, DC current, that is your I naught. So what should be the, if you consider inside this box, there is nothing that you have loss product. So what should be your output power then? That should be your P naught, right? V naught over I naught. Right?
Yes, sir.
And then here, since this is DC, you are using resistance, right? So what should be the power that the transformer is providing? Is this AC or this is DC?
AC.
AC. So here you should have the same VRMS and IRMS. And if you use a resistive load, then what should be the power factor of this component?
Sir, 1.
Current and voltage will be in phase, right? You have this type of thing, but the current that is going through the transformer, it will be going in the reverse direction, right? Meaning that the current will be exactly in phase with the input voltage. You get my point, right?
Yes, sir.
So what should be your power factor? 1, right? That should be your PSC, right? So out of this output, how much this secondary of the transformer you are utilizing to get this output, that is called transformer utilization factor. And since the power factor is 1, so instead of PSC, we are writing this as VRMS multiplied by RMS, because here you have a DC component and you are connecting it with a resistive load. That's why the power factor is 1, right?
Yes, sir.
Question.
Did you get my point?
Yes.
Yes, sir. I have got it.
Assalamualaikum, sir. So we got another class by 9 p.m. So
Yeah, that is the class from Mizan Bhai, right?
Yes, sir.
Okay. So just tell him to wait 10 to 15 minutes because I just want to finish this thing and we will start a new topic from the next class. So just give me 10 minutes, okay? So now, what should be your crest factor? CF, it should be IS
Peak by average.
peak divided by IRMS. So what should be your IS peak? It will be the same thing, but this peak, it should be what? Your voltage peak divided by R, right? So we can write it as Vm over R. And what is your IRMS? We calculated IRMS here, right? So IRMS, Vm over root 2 R. So this R will cancel out, this Vm will cancel out. So it should be root 2. And for the last case, what should be the input power factor? What should be your input power factor? We have already clarified that, right? What should be your input power factor? Since you are using a resistive load,
One, sir.
so your input power factor should be 1, right? Okay. So now, just I will take 5 more minutes and then I will let you go. Inshallah. I don't know whether I have gone too fast in this class. Okay, so now suppose you have a full wave breaker.
Sir, we have another class from 9 p.m.
I have already discussed that. Just give me 5 more minutes. It's the Mizans by class, right?
Yes, sir. Yes.
Just 5 minutes. I will let you go. So now, this type of question I gave you in the exam, right? Suppose this is my V input. And how should be my output? So suppose this is E and this E is like this. It's a constant E. So what should be the output then? Can anyone tell what should be the output?
Vn minus E.
So as the input voltage is lower than the battery voltage, so this diode D1 and D2, their cathode will be at higher potential as compared to the anode. So in that case, this D1 and D2, it will be in reverse bias. So that's why they will be turned off. So there will be no current through the resistor. If there is no current through the resistor, so the output voltage will be same as the battery voltage, right? So up to this point, you will have the voltage similar to the battery voltage. That is your V0. And after that, when your input voltage during this portion, when your input voltage is higher than your battery voltage, so what will happen? So here you will have the same input as the input here. And for the negative half cycle, you will have the same replica. So up to this portion, there will be no output voltage. The output voltage will be same as the battery voltage. And then after this portion, the battery voltage will be again that. And during this portion, this will be your output. And what should be your current output? So when there is no current, that's why your battery voltage appears across the output, right? So your current will be only available during this portion. So here you will get the current. Like this. Suppose this is alpha, this is beta. And what should be this value? This value should be, suppose this is my Vm and this is E. So this current voltage, it should be, the maximum voltage, it should be Vm minus E divided by R. So from here, we'll discuss in the next class, okay? So yeah, you can leave now.
Sir.